Okay, this is going to be a video to show you how to think about number 10 in the energy packet. All right, so we have some kind of ramp trying to get a crate up to the top of a loading dock. And the idea is, do we want to try to use a shallower ramp, or do we want to use a steeper ramp, or even just lift straight up in order to do the least amount of work? All right, so to figure this out, I want us to start with the idea that work is defined as the force applied, cosine theta, times the distance over which the object moves. And this theta is the angle between the force and the distance the object moves. So for the guy pushing the crate, here's our crate. There's the vector that represents force of person on crate. That's the force we want in here. This distance is the distance over which he pushes. That will be the length of that ramp there. And this angle will be the angle between the direction of the crate's motion and the direction of the push. All right, and since those two are both in the same direction, the angle theta equals 0 for this case. Now what I'm going to do is figure out, well, how long are the distance and what is the force? So let's just make up a value. Let's just say that the loading dock is 2 meters high. 2 meters high. And let's try two particular angles. Let's try an angle of 30 degrees, and let's do the same thing at an angle of 60 degrees. Again, this is 2 meters. Okay, so to figure out the distance there, we need to know that sine of 30 is equal to the opposite, 2 meters, over the hypotenuse, which is the length of that ramp. And if you do that, you get the length of the ramp, d in this case, is equal to 4 meters. Here, sine 60 equals 2 over the hypotenuse, and d here equals 2.33. All right, now we need to figure out how much force does the person need to exert to move this crate. Well, let's assume they're moving at a constant speed. So what that means is that for this crate going up the ramp, the forward push from the person on crate needs to be balanced by the backwards pull from gravity. That's Earth on crate, but only along the x-axis. Let's make that the x-axis. The x-axis is going to go like that. All right, so this is a good review problem for that way, because we can come back to our work with forces in vectors. All right, let's start with the 60-degree angle. Okay, let's say that's 60. So in that case, if that's 60, this angle in here is 30, and that will allow us to do some trig to figure out the weight, the x component of the weight. All right, so what we can say is that if that's 60, that's 30, so cosine 30 is equal to the adjacent side, Earth on crate, and the x over Earth on crate.